Welcome to the multivariable calculus section. In this section, we'll be discussing the fundamental theorem of line integrals. So that sounds relatively familiar, right? So in single variable calculus, we had the fundamental theorem of calculus, which is presented above. So the fundamental theorem of calculus stated that the integral from a to b of f prime of x is equal to f of b minus f of a, and this allowed us to state that definite integrals were valid, basically stating that the integral of the function from any domain or interval would be equal to the difference between the two. So essentially what the line integral, the fundamental theorem of line integral, does for us is it proves that we can take any path that starts from an initial point and goes to the next point. We can say wherever that path crosses is actually the difference between those two is going to be the value of that path. So essentially what we're stating is that the del of f times or to the dot product of dr is equal to the function minus the function at separate points, essentially. So if we were to look at this topography map on the right side and we said, what is the value, what is the length of this path integral? What is the value of this curve here? What is the length? All we have to do by the fundamental theorem of the line integral is say, okay, this path intersects here and this path intersects here. That means that this line integral is just 50 minus 30, and the length of the curve is equal to 20. So essentially that's what the fundamental theorem of line integrals does. And there is a large proof on the website and an additional problem where there's different utilizations of the fundamental theorem of line integral. This is just an example. So that's it for the fundamental theorem of line integrals. If you need additional assistance, there's a bunch on the website, and I hope that helps.